Welcome to part 3 of organizing data. Graphs and charts for quantitative data are the topic of this part of the lecture. First, we're going to be looking at dot plots and stem and leaf plots. Then we'll move on to making histograms with Excel. Dot plots and stem and leaf plots are quick and easy ways to get a graphical representation of our data. Historically, these were developed for use in the field when a researcher had just a notebook and a pencil available. They turned out to be useful enough, though, that they are still sometimes used even with technology. Let's take a look at these data. These were the price of DVD players, apparently from some time ago, from various retailers, and these are the data that were collected. The way these data can be represented is to first of all draw a number line and then to place a dot over the number line corresponding to each observation. Let's get a cursor here. So for instance, this 210 is represented by a dot over the 210 here. On the number line, you'll notice there are two dots in that column, and that's because there's a 210 here and a 210 here in the data. There are two observations of 210. 199 appears here, here, and here in the data. There are three such observations and therefore three dots. What this does for us then is to make a rough and ready kind of something like a histogram that we can construct quite quickly. Another advantage of this is that suppose we had, say, another set of data that we'd like to compare. If we had another one of these tables, we could then build the dots underneath, growing down rather than up for those data, and it would make it easy for us to compare the data in two different groups. Stem and leaf plots are next. Actually, I think what I'm going to do in this case, in the interest of time, is to skip that data set and let's start working with this one right here. Suppose we want to represent these, again, with a quick and easy way that we could do with simply pencil and paper. That stem and leaf plot, the basic one, we'll find labeled A here. Again, we need our cursor. This is figure A. Figure B is over here. Two different ways of representing those with the stem and leaf plot. On our stem and leaf plot, we read a 19 here and a 9 here. This is supposed to be read as a single number. 199 represents that minimum observation in the table right here. 200 is a 200 from the table, and we should be able to find a 200 in there. 202 represents a 202 from the table, etc. We can find one right there, for instance. There's the 200. 20, you find an 8 here and an 8 here. What that means is that 208 is in the table twice. So there's one there and there's one there. You see a sequence of 4 zeros here, meaning 210 is in the table 10 times. Another feature you want to recognize about the stem and leaf plots is that as you read from left to right here, these digits are in increasing order. That's really quite handy in some cases. Take a look, for instance, on take a look on this row right here. We see a single 1 here. It's easy to see that this one observation is clustered at the lower end of the range of 0 through 9 that are possible. If we had, say, 3 observations in here, we had a 1, a 2, and a 4, then we could quickly see that all of those observations are in the lower half of the possible observations we could record in that column. Now, in this particular case, we see that we're only getting 4, essentially it would be like 4 bars in a histogram, and we might be able to see a little more of the pattern if we could split these, each of these into 2, and that's what we mean by split stems. So the stem the stems are the 19, the 20, the 21, and the 22. They are all but the last digit in these data. Now what we could do would then be to record the 19 twice here, the 20 twice, the 21 twice, etc. And what we intend to do then is that digits 0 through 4 could go in this row, representing 190 through 194. Digits 5 through 9 could go into this row, representing possible values of 195 through 199. If we do that, we get quite a bit more information about the overall shape of our distribution. You can see that it's perhaps not too far from symmetric, but it appears that this peak is occurring in the first half of the 210 range, and that's something that's not maybe quite as easy to see here. Also, that peak is shifted a little bit towards the high end of the possible values. That is definitely not as easy to see in this example. Now, those are dot plots and stem and leaf plots, but quite often these kind of data are much easier to see with a histogram. So these are the cholesterol data, the total cholesterol, blood serum cholesterol for 20 patients who have relatively high cholesterol, and we'd like to do those with Excel. So we have an Excel spreadsheet prepared for us here, and these are simply those values that are in the chart that you saw earlier. Now these have been sorted in order, but I'm going to show you a method for making a histogram that won't depend on that. So what I'm going to do is select a cell here. It's going to be convenient to leave a blank cell. So then we'll go one below the end of the table here. I'll type in min for minimum, max for maximum, and I'm going to enter a formula here, so I'll press equal. MIN is the name of the minimum formula. So we'll double click on that, and then we'll highlight this column by clicking and dragging. Type in the closing parenthesis, and it tells us that the minimum observation there is 199. Of course, we could tell that easily here because we had them sorted in order. Equals max. And let me show you a way to speed this up. I click on the top one. I'm pressing the Shift and the Control key, and then I press the down arrow, and it automatically highlights to the end of the column. Press enter, you automatically get the right parenthesis here was added for us. That shift control down arrow trick is very convenient if your column extends beyond the limits of one screen. So that's a very handy trick to know. Alright, the reason we want that is what we want to do is come up with a width for our categories in our histogram. So what I'm going to do is say that's equal to, then I'll click on the max, press the minus sign, click on the min, close the parentheses, and let's say we'd like about 7 bars in our chart. So I'll press an enter there, and that gives me 3.14. Now I should probably round that up or down. Let's go with 3. And now I know that my minimum observation is 199. So if I'm going to go with 3, let's make our first entry. Let's make that 198. I'll actually not use that one, but it's convenient to have. Equals, and I click on this, plus 3. And what I need to do now is to drag this down so that I get an upper number that's just more than 221. Now I was very lucky in that case. 222 is just right. Had I gone a bit too far, I can always grab that sizing handle and bring it back. If I had not gotten far enough, I can just drag it down and get the number that I need. This 198 is not going to be useful, so let's just take that out, and this one should, what do we have here? That should have been 201, so I'll make that one hard-coded 201. Delete this, and actually I'm going to highlight these, cut, and paste so I don't have a blank up above there. Alright, it is going to be convenient to have a label here for total cholesterol, because that is going to end up in our histogram in the legend, and that'll be nice to have. Alright, so what I have now, these are known as the bins. They are the upper limits for the categories in our histogram. So let's click on data, data analysis, histogram, and OK. Alright, the first thing that we need to fill in is the input range. So let's highlight that and delete. We'll start over again there. What we'll do is Shift Control down arrow to automatically highlight those. Bin range, that's what we were constructing here. I'm going to include that label, and I'm going to make sure that I have the labels checkbox checked here. Output range, that's simply the place where I'm going to, the upper left hand corner, where I'm going to begin to make my output. So let's start that here about F2, and I want to make sure that chart output is clicked, and that's all I need. So I press OK, and that gives me the beginnings of a histogram there, and also a frequency chart that can be useful to us. Now this, as usual, notice when I click here, the chart tools is enabled, and I have various options for design, for layout, and for formatting. For the design, the usual layouts are available here, and you can experiment with them and see which one that you like. Another possibility is, as with our bar charts, if I click on one of these and right click my mouse, I can format the data series. That allows me to adjust the gap width between the bars. Now, officially, a histogram, at least what most statistics books will tell you, is that a histogram should not have any gap between the bars. Something about this that I don't like is that I don't have any borders on here, and in the case of bars that are the same height, it can be hard to read. So the way we can fix that is to go back here. I'm right-clicking my mouse, Format Data Series. I can set that gap, rather than 0, I can set that to about 5%, and what that appears to be is a white boundary around each bar. What it actually is a tiny little gap, but it works very nicely for our purposes. This legend here, since we have only one series, is not useful. Highlight it, press delete, that'll take care of it. Frequency is hardly a useful word for a title, since histograms always represent frequency, or perhaps relative frequency. So what I'll put here is what we're measuring is total blood serum cholesterol for these patients. Axis title, again, that would be frequency. Probably that's what we would assume, so let's simply take that out. Alright, that gives us a basic histogram right there, and that completes our discussion of how to create a histogram with Excel. Let's take a look at a little more interesting problem with Excel histograms. Um, Babe Ruth played 15 years for the Yankees, and these are the number of home runs that he hit each year. Originally, we wanted to make a dot plot of those, but let's make a histogram instead. Of course, there's long-term debate among those who follow baseball statistics about whether Roger Maris really was the player that Babe Ruth was. I think that's a fairly easy question to answer. But you also have the records of Mark McGwire and Barry Bonds available. Why don't we take these data and start making some comparisons by making some histograms? So we'll do that by starting up Excel again, and these data I've already entered. By the way, I think there might be something missing here with Barry Bonds. I have 19 seasons for him. I think he actually played 20, so I don't know what's missing, but that's at least a good part of his record. All right, what we're going to do here, let's make a first histogram for Babe Ruth, and we're going to do the usual thing. We'll make a formula equals min, left parenthesis, I'll click on the top, hold down Shift, Control, down arrow, press enter, and that gives me the minimum for his record. The minimum number of home runs he ever hit in a season was 22. Here equals max, double click on that. I need a range, so I'll click here, Shift, Control, down arrow, automatically selects the column, press enter, and his minimum to maximum was 22 to 60. Now, these formulas can be simply copied by grabbing this lower right hand corner of the highlighted cells, if I can get a hold of it, drag them over, and I have that information now for not only Babe Ruth, but for Maris, McGwire, and Bonds. Let's take a look here at a comparison, say, between Babe Ruth and Roger Maris. Well, I'm going to be making a histogram, so it will be convenient actually to make one for both of these players separately, and then to make a combined histogram that makes it for easy comparisons. What I'm going to do is start my first bin at 10, and the reason I wanted these mins and maxes is to get some idea of how wide these should be. So let's say we're going to compute width here, and we're going to do that. Left parenthesis, I'll take my max minus my min, close the parentheses, divide by, let's say we'd like around 6 bars in our 6 categories here. 6.33 is what we get here, and we can copy that all the way around. Looks like since we'd like to come up with a bin range that would work for any of these, let's go with about 10. So I'm going to say equals plus equals. I'm going to click on the one above, add 10, and I need to get up to the maximum for all of these is 73, so I need to get up to about 80. Oh, there we go. The home runs here, that will be convenient to have that label, so make sure you have that in your setup. Alright, data analysis, select histogram, press OK. What I'm going to do first is make a histogram for Babe Ruth only. So selecting here the input range, I'll clear that out, select, then Shift, Control, down arrow. By the way, the Mac version of Microsoft Office will not do that, so yet another reason probably to be using your Windows version. bin range is here. I want to select that title, that label. Output range, well, click the upper left corner of where you want your output. Let's put it right here and make sure that chart output is selected. I'll press OK, and that gives me the histogram for Babe Ruth. So let's label that for what it is. Or for who it represents. Alright, I'm going to do this over again now, let's say for Roger Maris. So, same thing, data analysis, histogram. Now, my input range is here. My bin range is right where it was before. It's these cells right here. The output range, I'll definitely want to change that. So let's click about here, and we have labels. I think we're ready to go. And here we have the histogram for Roger Maris. Alright, now these histograms are different enough that it's really fairly easy to see that Babe Ruth's record is significantly stronger than Roger Maris's record. The maximum number of home runs of 61 in a season appears to be an outlier for Roger Maris. So his overall record was clearly clustered in an area much lower than Babe Ruth's. If we do this again, though, let's say for Barry Bonds, the results are not quite so clear. So let's do yet another one. I could simply repeat these steps for Barry Bonds, but what I've done is already computed those ahead of time, and then I made a frequency distribution which has both Babe Ruth and Barry Bonds records here by season. These are the number of home runs in a season, and what you want to notice here is that these values are left justified and those are right justified. There's a reason for that. If you look up here in my formula area of the interface, you'll notice that there's a single quote here. What that does is it makes this 10, 20, etc. Each of those are now being treated as text rather than as a number. That's important to get Excel to treat these values as I want them treated. So what I'm going to do now is to highlight this table, including the top of the column here that has the label. Then I'm going to go to Insert. I'm going to choose a bar chart, and I'm going to choose the second option here, the stacked bar. And you'll notice that this has given me a histogram with the bars for Babe Ruth pointing out to the left, those for Barry Bonds pointing out to the right. Now, the way I got that to happen is for Ruth's record, which you could read up here. His frequencies are 0, 0, 2, 2, 7, etc. Here I entered those as negative numbers. The reason I entered those as negative numbers is that on our number line here, the negative numbers will project off to the left, the positive numbers for Barry Bonds will project off to the right, and that works rather nicely. If I click one of these data series, right click, Format Data Series, I can reduce the gap to get a little bit nicer looking chart output. And it's at this point you can actually see what the overlap does. If I were to slide this back and forth, you can see those don't line up anymore. So we want overlap at 100%. Babe Ruth's record is considered one series. Barry Bonds' record is considered another. So I can close that now. All right, if we select in here, this enables my Chart Tools menu. Design gives us access to the chart formats, and I think that this one might work a little bit nicer. Finally, something that is a little bit awkward is I am getting negative numbers down here. Now perhaps that's not so bad, but that can be addressed by looking at the axes under layout. Primary horizontal axis, I'm going to choose more options. Under the more options, I can go to number, custom, and that can be added. And when I added that, you notice that the negative signs are now missing. So that makes that a little bit easier to read. Now in this histogram, you can see that Barry Bonds' record really does seem to be shifted off to the right. That is in the higher the seasons with a lower number of home runs. He seems to have more of those cases, and Babe Ruth seems on the whole in the middle of his record to be a little bit stronger. Up here is a greater number of home runs per season. You do notice though that right here Barry Bonds did have one season with just an incredible number of home runs, in a certain way not so very much different from Roger Maris, with one really wonderful season, Babe Ruth being on the whole very, very strong. However, there is no doubt that there's a lot more competition here between these two than there are between the case of Ruth and Maris. Of course, people who know about baseball will tell you that there are a number of other factors to consider, and statistics can't tell us about that. But it can allow us to compare these two records pretty conveniently. Now, of course, you can do the same sort of things that we've done before. We could edit our title, for instance. And we could copy this histogram alone and paste it into a Word document if we were writing a report that we wanted to be able to communicate these results to our readers. Well, that takes care of both histograms and comparative histograms. Let me show you one other thing that we can do. This really goes back to qualitative data, but it's really quite convenient, and it's just another approach to making these kind of charts. In this particular data set, what I have are the kind of fountain drink that was ordered at a restaurant during a certain period of time, and I have added a label here. I changed the color just to highlight the fact that this is a label here and not data. Now in the past we've talked about the possibility of doing something like highlighting these data, then we could sort them and it would allow us to be able to make our own frequency chart. There's nothing wrong with doing that, but there is an easier way. What I'm going to do, of course, is to highlight these. So Control Shift down arrow highlights all of the cells with data, and since those did run off the or at least to the end of my page. It was convenient to be able to do it that way. Then I'm going to go to Insert, and under Insert I'm going to choose the Pivot Table option. Click on Pivot Table, and give it a location to start in. Now that makes a table. This doesn't look like it's very helpful, and it isn't just yet, but over here on the right I'll take the drink ordered and copy that into row labels and copy that into values, and what that's done for me is it has made the frequency distribution without me needing to intervene and do those counts by hand. Once that's been done, then of course I could make a bar chart or pie chart, whatever is convenient. So I can go to Insert, let's make a pie chart in this case, say something like that, and do my usual editing. So of course once we have this, then we could change our layout and make the usual kind of edits as we choose. So there's another option for you if you are working with qualitative data and there's enough of it that you'd rather not do the counts by hand. All right, that takes care of part 3, and that's the end of our basic summary of how to summarize and present data using charts and graphs. Thanks for watching.